Today we're going to solve compound inequalities. This should be new, so we're going to start with the basics with some definitions. First, a compound inequality. It's when two simple, the inequalities we've been doing, are combined into one statement by the words and or. A disjunction is composed of two simple inequalities connected by the word or. It is true when at least one sentence is true. So only one part has to be true for the whole thing to be true. Versus a conjunction, which is composed of two simple inequalities connected by the word and. It is true when both sentences are true. So a conjunction has to have both parts true for the whole thing to be true. But a disjunction only has to have one part true for the whole thing to be true. We're going to start with the graphing. And in the beginning, we're going to do 3 graphs for each problem. After we practice this, then I will let you just, if you're able to, just do the one final graph. But in the beginning, we're going to start with 3 graphs. A disjunction. My key word here is to smash the graphs together, or you're going to combine them. You're going to take the 2 graphs, graph them individually, one on top of the other, which we'll do in a second, and then create the third graph by smashing them together. Let's do this. X is less than negative 2. I've got my 0, my 2, my negative 2. I'm going to set up the next one. X is greater than 3. Notice I'm going to make sure that my number lines match one another so that my 3 is out further than my 2. And then my last one will be X is less than negative 2 or X is greater than 3. And here I'm going to put my 2, my 3, my negative 2, and my negative 3. Okay, so let's talk about graphing. X is less than negative 2. Open circle on negative 2, less than, shade to the left. X is greater than 3. Open circle on 3, shaded to the right. If I could pick up this first graph and smash it onto the second graph, your final answer would be X is greater than 3 or X is less than negative 2, showing both parts on one graph. Now, this is the most typical looking disjunction graph. We're going to talk about 2 others. Again, start with your 3 graphs. So we've got X is greater than negative 1. I have my X is less than 4. And then I have my final disjunction graph of X is greater than negative 1 or X is less than 4. X is greater than negative 1. Open circle on negative 1, greater than is to the right. X is less than 4. Open circle on 4, shaded to the left. Now, if I could pick up this graph and smash it onto this graph, everything would be shaded. This is one of your special cases that we solved, where it's all real numbers. Last disjunction. So we're going to start with X is greater than 0. And since it's 0, and you have to have 3 numbers on there, I just look at the other inequality and say, okay, it's 3, so I'm just going to use 0, 3, and negative 3. X is greater than 3. and then my disjunction. X is greater than 0, open circle on 0, shaded to the right. X is greater than 3, open circle on 3, shaded to the right. Now this time if I could pick up the first graph and smash it onto the second graph, everything from 0 up would be shaded. That is your disjunction graphs. Again, the first one is the most typical one where it's going in opposite directions, but you can have these other two cases. Now we're going to get into conjunctions. And the key word for conjunctions is where the graphs are overlapping. Where are both parts being shaded? And the part where they're both being shaded is your solution. We're going to do the same thing we did with disjunctions. We're going to set up our three graphs. So I have my x is less than -2. I have my x is greater than 3. And I have my conjunction x is less than -2 and x is greater than 3. So we graph them. X is less than -2. Open circle on -2, shaded to the left. X is greater than 3. Open circle on 3, shaded to the right. Now we're looking, where do these graphs overlap? They don't. So this is a no solution graph. If this were a disjunction, you'd have a solution, but because it's a conjunction and looking to see where they overlap, this is a no solution. X is greater than -1. X is less than 4. So x is greater than -1 and x is less than 4. We want this conjunction. Open circle on -1, going to the right. Open circle on 4, going to the left. Where are these graphs overlapping? They are overlapping right here. So my final answer is between -1 and 4, between the two. Now some of you are probably saying, what if this was greater than or equal to? Well, then this would have been shaded and this would have been shaded because -1 shaded here, -1 shaded here, -1 shaded here. X is greater than 0. Just like with disjunction, because it's 0, I'm going to use 3 and -3 because I looked at my other inequality. X is greater than 3. Open circle on 0, shaded to the right. Open circle on 3, shaded to the right. Where are they both being shaded? Where do they overlap? Right here. So my final graph is an open circle on 3 shaded to the right. It's open because this part's not shaded. Both would have to be shaded for this to be shaded also. There are your 3 types of conjunction graphs. The one where you have the 2 circles and it's overlapping between the 2, that's the most common type of conjunction graph. Conjunctions can also be written in this form, where they are connected between the 2. And if you were to break this up, which you can do, and we're going to do right now, it's -2 is less than x, and x is less than 3. And this is how you break it up. And I'm going to rewrite this. I'm going to flip my variable over so it's on the left. But notice the open part is the x. The open part is still towards the x. So x is greater than -2. And then I have my x is less than 3. And then I have my conjunction. Open circle on -2, shaded to the right. Open circle on 3, shaded to the left. And my final graph is where they're overlapping right here. So it's open circle on -2, shaded to the 3 where there's an open circle. Typically, if it's written in this format, notice it's between 3 and -2. It's between 3 and -2, the most common type of conjunction graph. Now, we are going to practice, so at this point, we're going to pause, and there will be an assignment that goes with just practicing the graphing. I find that if we practice and solve, it gets confusing. Now we're going to solve. This inequality is a conjunction because it's connected. I'm going to show you how to solve it 2 different ways. First is I'm going to break it up into the 2 parts. And if you break it into the 2 parts, this whole expression right here has to stay as 1. You can't just split it down the center. So when you do this, you get -9 is less than 6x plus 3, and 6x plus 3 is less than 39. So you solve it. But you've got 2 problems to solve now. Add the opposite, you get -12 is less than 6x. Divide by 6. -2 is less than x. And -3 on both sides. You get 6x is less than 36. Divided by 6, you get x is less than 6. So here is my answer. We will graph it in a second. I'd like to show you the other way you could solve this. We're going to leave the compound inequality, this conjunction, together and solve it as 1. I personally think this is a little bit easier, but some people have problems seeing it in the very beginning. I want you to think of this as 3 different parts. Notice here we subtracted 3 from both sides, we subtracted 3 from both sides. Here we want to isolate the variable, so we're going to subtract 3, but we're going to do it from all 3 sides. Notice here, here. So when we're left, we get -12 is less than 6x, which is less than 36. And if you notice to the left, it's the exact same line that's here, just put together. Here we divided by 6 for everything. We're going to divide by 6 on all 3 parts. So you get -2 is less than x, which is less than 6. If you do your graphs, we have our x is greater than negative 2. And we have our x is less than 6. And then our last one, and I'm running out of space, so I have to go over to the side a little bit. We have our negative 2 is less than x, which is less than 6. Open circle on negative 2 to the right. Open circle on, excuse me, that shouldn't have been a negative 6. Open circle on 6 to the left. I want to make this a positive because that is incorrect. And you're looking to where they overlap. They're overlapping between negative 2 and 6. Here you go. At this point, if you were able to do just the final graph without needing to do the previous two, you should do that. If you are not able to see the final graph without drawing the first two, then please continue to do that until you're comfortable jumping right to the end. A disjunction. Unfortunately, with a disjunction, you can't put them together and solve it the simple way that we just did with the last one. You have to do the separate problems as separate problems. We're going to subtract 8 from both sides. We're going to get 2x is less than negative 2. We're going to divide by a positive 2, meaning we do not flip the inequality symbol. We get x is less than negative 1. Over here, we're going to add 2 to both sides. We're going to get 3x is greater than 15. Divide by 3. X is greater than 5. So our answer is x is less than negative 1 or x is greater than 5. Notice I'm writing this as one answer. I'm going to continue to do the 3 graphs just in case you still need them. And again, if you are able to hop to the final graph and you can see that, go for it. X is less than negative 1. Open circle and negative 1 to the left. X is greater than 5. Open circle and 5 to the right. Smash them or smush them together. And that's your final graph. Last thing we're going to do, you should be able to reverse the process. You should be able to look at this graph and write the inequality from there, or write the compound inequality from there. So if we're looking at this, this is a typical disjunction graph going in opposite directions. Just write the inequality as you see it. X is less than or equal to negative 4. Or x is greater than, because it's an open circle, to 2. Right here, my conjunction, because it's between the two, the overlapping area, and I'm going to write this connected together. I'm going to put my x in the center because it's less than or equal to 4. It's smaller than 4, but it's greater than negative 2. And if you can't see it that way, you can write it as x is greater than negative 2 and x is less than or equal to 4. That's everything for compound inequalities. There are no try problems. It's all just a lesson. Bring your notes to class and we definitely will go over this because we're going to need to do some practice.